We're live. Welcome to our very first Facebook Live. I have no idea what I'm doing, so please, we'll figure this out together as we go along. So if you're just joining me, my name is Tim Van Milligan. Let me see if I got two screens going on here, and I'm seeing who's in our chat. I see Steve Thymeke. Is that your name, Steve? We're showing 12 people in the room, so that's more than I expected. I thought I was just going to be one person, which is the people here in the building just kind of watching me to make sure that I'm not screwing up too bad. The purpose of this Facebook Live is to do some Rocksim training. We get a lot of calls all the time of people learning Rocksim, and what we want to do is to say, you know, we have a Facebook Live and we can answer your questions live and show it on the screen so that you learn. So this will help us in our office to kind of divert questions back to me so that I can answer them live. Also, what we want this to be is for people to become experts in Rocksim so that we can spread the word and reach a bigger community of Rocketeers. We really believe in Rocksim, in what it can do, the power that it has in rocketry, so that it makes you a better Rocketeer. It makes the hobby safer and a lot more fun and more educational. So that is what our goal is with this Facebook Live. I am looking for questions. So if you have a question, go ahead and type it in now. If you're watching this on replay, what you'll have to do is to submit your questions by email, and then the next time we do a Facebook Live, we can try to answer those questions for you. So I am seeing Christopher Mick. Hello, Christopher. Hello, Dave. No questions so far. So what I'm going to do is I'm going to switch over to my screen. And so now you're seeing my screen. I'm going to make this a little bit smaller. So what we're doing is we're going to try to do this every Friday. That's why we have this little tips and tricks over here. And I'm going to get rid of that. So now you're seeing my screen. So the first thing I want to do is kind of go over the interface, unless somebody has a specific question. And we have one already from Dave. He says, when I add nose weight, the static margin doesn't change. How to correct this? Okay, so what I wanted to do was to go over the interface, but I'm going to answer Dave's questions first because I only have an hour for this. So I want to make sure that I get your questions answered. So he's adding nose weight. So here in the design, we have a design, and this rocket here is the Skymetra. I have it here just as an example, you know, real life versus what's going on the screen. So he's putting nose weight in, maybe clay nose weight. And the purpose of putting weight in the nose cone is to make the rocket more stable. And he's saying his is not changing. So what that tells me is that he's got a setting turned on. So let me go here on the screen, and here's my nose cone. So this is the parts tree. So a rocket is the sum of the parts, and they have to be in a specific order. And when we put them in from the nose downward. So the nose cone will always be first, and then we work downwards along the rocket. So into the nose cone, he's putting nose weight. So here's my nose cone, and I'm just going to highlight it in the parts tree because now I'm going to start editing this. And to put nose weight in, it's a special component, and you see it over here on the right side, and it's called a mass object. A mass object is anything that doesn't have a specific geometry. Like think of a lump of clay where you can mold it and shape it. So it doesn't have a defined surface. So you can use anything and specify almost anything as a mass object. Things like payloads that you put into rockets. Like I said before, clay, maybe you're putting in sand for nose weight, or water, maybe, or somebody putting in a beer can, although that would have a specific dimension. There's contests in high power called beer lofting where they put in beer cans. That's why I mentioned it. Nuts and bolts that that are a little bit heavier than clay that you might want to put in, those would also be mass objects. So I'm going to add a mass object to this rocket, and the first thing that happens is it always brings up a database that you can select from, and I'm going to cancel out of that because I want to enter my own mass object. It has a name, and the classification is called general. And there's also shock cord, because shock cord is another object that doesn't have a defined shape. Once you wad it up, it's undefined. And then you have a mass and a location. So right now on my screen, if you look down here, it's highlighted in blue. That's the current mass object, but I haven't given it any mass yet. So I'm going to throw in, 28 grams, which is about 1 ounce, and hit the tab key on your keyboard. And now I have to change the location. Okay, so now I'm using the slider bar. I'm just sliding it back into the nose cone. So now what Dave was saying, so when I slid it back, you saw it move. And what he says is his static margin is not changing. So the static margin is the relationship between the center of gravity and the center of pressure. So the center of gravity is easy. So if you look at my face right here, I'm balancing the rocket, and I'm just balancing on my finger. And so where it balances right there is the center of gravity. Let me go here. Okay, so right here is my center of gravity. Now the center of pressure is a different point on the rocket, and that is where all the aerodynamic forces balance. So gravity is where all the gravity forces balance. So we have acting over here, pulling the nose cone down. We have gravity acting over here, like on this, the engine mount and the engine hook. Gravity is pulling it down here, but where it balances is called the center of gravity. The center of pressure is where the aerodynamic forces balance. And there's two aerodynamic forces, and these are lift and drag. Unfortunately, you just can't balance it on your finger. It's because the air is moving, it's changing that center of pressure location, and we need to figure out where that is on the rocket. And Rocksim, one of the things it figures out where that center of pressure is, where the lift and the drag are concentrated, where we say they're concentrated. We as engineers, we have lift and drag all over the rocket, just like we have gravity acting at different locations on the rocket, but we want to simplify things and make it one little point. And that point is called the center of pressure. In airplanes, it's called the aerodynamic center. So what Rocksim does is it will, let me make this screen just a little, oops, wrong one. I can't grab it. There we go. Okay, so what Rocksim does is it figures out where the center of pressure is and the center of gravity. And so this icon right here, a circle with a cross in it and opposite sides are colored, that's the center of gravity. And the center of pressure is where the aerodynamic forces are, and that's this red dot right here. Now on your computer it may be a different color because of the preferences. Rocksim allows you to change preferences, but the symbol is a circle within a circle, and then the inside circle is shaded in. So the relationship between the center of pressure and the center of gravity is the static margin. And the further forward that center of gravity is, the higher the static margin. And we see that static margin right here and it's laid out in kind of this summary. Right now it's saying 8.07. So what that means is that the relationship is 8.07 body tube diameters ahead. You know, the distance apart is 8.07 body tube diameters, because we use the body tube as kind of a reference, so that no matter how big the rocket is, it's kind of a simple relationship. And we call this calibers of stability. So we have 8.07. So if it's here and you take the body tube diameter and you move it 8.707 body tube diameters forward, that's where the center of gravity, that's where Rocksim thinks it is. So what he's saying is, on his screen, when he moves the location, that center of gravity is not moving. So what that tells me is he's got mass override turned on. So let me turn it on and I'll show you what happens. Okay, so I'm going to save my changes. So I put a mass object over here in the nose cone. So go here to this mass override tab and you click on it right there. And now, if this box right up here that says use the values shown below for all the simulations, if that is checked, that means you've specifically turned mass override on. Now this is dependent on the model. So you may open up a design and it's turned on already, or you may open up another design and it's turned off. So if your center of gravity is not moving, that tells me that it's turned on. So if I turn it on and I click on it, did you see what happened? That center of gravity symbol shifted because I forced it into a new location. So let me turn it off and then turn it back on. Okay, so now I can actually move it right here with these two inputs. And so you have to change the mass and then you have to change the location. So I don't know what the mass is. I'm just going to guess. You know, I'll guess 67 grams. So my sustainer. And so let me take that off. So now I just have the sustainer, because you have to do the sustainer and booster separately. So my sustainer, say I measured it and it was 67 grams. Now I have to say where it actually balances. So I'm going to come over here and balance it on my finger and say, now that is the center of gravity location. And then I measure from the tip to here. And that's probably about 11 inches. So I'm going to come over here and type in 11 inches and hit enter. And okay, so what happened is the reason it didn't move, you see it didn't move back to 11 inches because I'm showing two stages here. So if I turn one stage off and just show the sustainer, it should shift back. See what happened there? It shifted from the nose cone back. And if I change that to 13 inches, watch the center of gravity hit as I hit the tab key. It shifts back even further from the tip of the nose cone. So now if I add the booster, so if I weigh this, and so now the weight is higher. So I'm going to say, man, I made that 67 ounces, not 67 grams. I'm sorry, didn't notice that. I have to come over here. Okay. Okay, so if I weigh this, let me change my weight back. 67 grams. Nobody's catching me on that. Okay, so 67 grams. Now, say my booster stage, this stage right here, weighs 20 grams. So hit 20. Now I have to put the booster into the rocket, and now I got to rebalance it on my finger and say here. Okay, so now this one is probably 14 inches. So here, let's say that first one was 11. So now the booster plus one sustainer is 13 inches. So now if I come over here and show the first stage plus the second stage, you'll see it shift back to about 13 inches. And I'm not quite back far enough, but that's probably because 13 inches is not far enough. So let's make it 15 inches. Yeah. I'm balancing it here. It's kind of like right where the tip of the fin connects to the tube. Okay, so I'm going to shift it just a little bit further forward, so I'll go 14.5 inches. Hit tab. So now my center of gravity is in the right location. Okay, so if you add a nose weight, so now if I go back to my parts tree and I go to the nose mass and I change that location of that nose mass, you'll see now my center of gravity is not moving at all. So no matter how much weight I put in the nose cone, I've already forced Rocksim by using the mass override tab up here to say, this is where I want my center of gravity. So did that answer your question, Dave? So I'm going to turn that back off, and hopefully that's correct. Oh, look at this. If I scroll down on Facebook, there's more comments. Wow. Yeah, Adam caught it. Adam Bowie. Good job, Adam, catching me on my ounces. That's very perceptive. I really appreciate that. I wish you could speak so I could hear you, but oh, and Dave Inskeep also did see that as well. Okay, Michelle writes, when would I want to use mass override and when not? Okay, so that's a good question. So when to use it is actually if you've already built your rocket. Okay, so say in real life, I've already built my rocket and I've got it in Rocksim and things aren't matching up. Okay, so let's see if we can get this to match up. Let me go back here and take out that nose mass. So I'm going to delete the nose mass just by highlighting it from the parts tree and then clicking delete. And we'll say yes, delete that component. So now it's gone. Okay, so now say this may not be an example because I think I created this design myself. I'm just going here looking to see who the rocket designer is. Usually I sign my name when I create them myself. But I'm pretty sure I did this one. And when I put them in as exact as I can. So it may not match. So right now, I wish I had a scale right here. But we're showing that this rocket weighs 47.27 grams in this configuration. So if I weighed this rocket and it did not weigh 47.27 grams, this would be a case where you might want to use a mass override. Say this weighed 60 grams because all the extra paint and whatever you might have done, big heavy fillets, you know, thicker walled tubes, maybe you did some modifications to it. So if it doesn't weigh that and you want to just run quick simulations without redesigning and tweaking everything, this would be a good case for mass override. So mass override is for changes. If you want it more accurate, then you want to make sure that all the components are accurate because that changes the moment of inertia of the rocket, and that's going to affect the trajectory. But if you just want to run a quick simulation, say you're low on time, and I just want to do a simulation. If you're a teacher and you just want to get it done quick, so I would go to the mass override and say, okay, so my mass override is 67 grams. Say it's 60 grams, and the location of that is, you know, right here at the, right here about where the launch lug, I don't know, you probably can't see there's a launch lug right here. So then I would go here to the sustainer and then just move it to where that launch lug is. You know, I'd say maybe 7 inches. Yeah, I got to show just one boost, one stage alone. Okay, 7 inches is too far forward. Then I'd go 9 inches. See if that's closer, maybe around 10 inches. Okay, so now it's right where my center of gravity is. And now I would go and run a simulation and just get quick and dirty results. If I wanted more accurate, then I would go find out where the mass distribution really was. So I would start pulling components apart, take my nose cone off, weigh the nose cone, look at the nose cone. Let me turn this back off. Look at the nose cone and look at that mass of the nose cone. So I'd come here and my calculated mass right now is 4.27 grams. I would make sure that mass override is turned off, because every object can have a mass override. I make sure that I turn that off, just to make sure that my calculated mass is correct. This is going to give you the most accurate simulations. All right, so hopefully that answered that question. Okay, it looks like Adam answered Michelle's question already. Cool, Adam. Appreciate that. No more new questions. Okay, so since there's no more new questions, what I was going to do, I was going to go back to the beginning, and I was going to go over kind of the interface for people who are brand new to Rocksim. We kind of use these videos as training in-house as well. So when you first start Rocksim, it's kind of like clicking this button over here, which is the new button. And this will erase everything on your screen. And I'm going to say, don't save my changes. So when you first start Rocksim, you're going to get a blank screen just like this. What we always suggest is to open an existing design and then run a simple simulation just to get the feel of what the power of Rocksim is all about. So to open in a design, you can either go from the File menu and click Open, or you can just click on the File icon right here on the top of the screen. And this will bring up all of your existing designs. And it's going to remember the last location you opened, but when you're first starting it, it's going to open into your main folder. Mine is a little bit different from what you would probably see, because I've opened, I kind of store all my personal files in my own location. And on my computer, it's in my Rocksim Designs folder. But when you first open it up, by default, it will look into your data folder, into your designs folder. And then you'll see different manufacturers. But here on mine, these are the ones that I've been working on. Like I just did, I opened up the Skymetra. Let me see if I can open up another one that's pretty common, Apogee Aspire. So I'll click open that, and that will bring up the Aspire rocket. So going over the screen here, on the top we have our button bar, and this is kind of where you're going to start. This top of the screen here is our parts tree, and this you get to by going Rocket Design Components. Then you can scroll down and you can see all your components that make up your rocket. And then down here on the bottom of the screen is your view window. Now this view window, you can change the size. And what you do is you move your mouse up and down, and when you get kind of like right in the middle, you'll see the cursor change. And so I got a bar with an arrow pointing up and an arrow pointing down. That means I can click on it and I can drag it. So I can drag it up or down and change the size of the view window. So now there's a maximum size that you can get this view window by dragging. So I've maxed it out, and right now it's basically maxed out because of the components here, right here, because it's got to show all the components, so it won't smush this area right here. But if you want it bigger, you can detach it, and you just go to the bar here that you were just dragging, and you double click on it. So if you double click on it, it should detach. Come on, detach for me. Oh, click on that button there. Okay, so I detached it now, and now I can drag it and make it a lot bigger. So I can fill up my entire screen with just a window. And you can see all the other buttons went away. But I can now change the three-dimensional by going here to 3D. So now when I do that, now I have a 3D view of the rocket, and you can see my cursor has changed. So now if I use my mouse, I can click and drag, and you can drag the rocket around. And right now I have trackball mode on. So trackball mode means that it's going to follow my cursor. So when I click and drag, it follows. If I turn trackball off and I click, now I'm clicking and it's just following the click, you know. So the further away from the center of the screen you click, the faster it's going to rotate. So if I'm right here and I click slowly, you can see it's just slowly moving. If I go further away from the center of the screen, it's going to rotate faster. Personally, I like trackball mode, so by default I turn that on, and First Start Rocksim by default it is on. So now I can click and hold, nothing happens, but as soon as I start dragging, and it will drag around. Now you can also move the rocket around, give you more control if you hold down the shift key. You see if I click on the shift key, it turned to an arrow. And now if I click, I am actually, this is called panning. So I've panned the rocket around by holding down the shift key. But now if I click and drag, it's rotating around a new center. And sometimes it can get disorienting. So you want to get the rocket back to where the center of the rocket is in the center of the screen. Another thing to point out is, did you see the fin here? It changed to wireframe. What that is computer, it can't generate the image fast enough. So on slower computers, you're going to see wireframe a lot. On faster computers, you'll probably see it less often. So now if I want to get the rocket centered back in the screen, I'm going to go over here to this button, and this is called the camera controller. It's just 4 arrows, and if I click on that, it will bring up the camera controller itself, and you can see there's 2 buttons called recenter the camera or reset the camera. Both of them are going to move the rocket back to the center of the screen. Reset camera basically is going to say, you know, right now it's at a weird angle. If I reset the camera, it's going to move it right back horizontal like this. So right now if I click recenter, it just recenters the rocket. And if I click reset camera, then it's going to reset it back to horizontal like that. And you also have the same buttons over here to move the rocket around. And for some reason it's not working for me. I might have too many things going on. Let me close out. I can still move it around with my cursor, so that's fine. And we're gonna skip lighting for right now. If you want to know about lighting, I can show you that later. Let me just double check to make sure that there's any other questions that came in. Adam Bowie asked, can Rocksim open rocket files? And the answer is why? So that's the answer to that question. So why would we want to open an open rocket file? The reason we don't open rocket files is there's really no reason to. Because if you run a simulation in Rocksim, You're going to get everything right here. In the future, we might offer this. I've been thinking about it, but there's just so many designs that are already in Rocksim. And I feel bad for the people that have an open rocket file and they're too lazy to put it in Rocksim, because it is really easy to create a simple design in Rocksim. So there's really no, I think it comes down to just people, they just don't want to because it takes time. But it doesn't take a lot of time to create a rocket and run a simulation. You really only need 3 components to run a simulation. And that's a nose cone, a body tube, and fins. And once you have those, you can run a simulation. So on this particular rocket, I could delete everything else out of here except the nose cone, a body tube, and fins. And I could create a simulation. To run a simulation, I'll go over that real quick here, because we do recommend people run a simulation as quickly as you can so that you can see what actually is going to happen. So to run a simulation, there's another button along here on the top, and this is called Prepare for Launch. So if you just put your mouse over it, a little tooltip will show up that says Prepare for Launch, and we'll click on that. And this is going to bring up, now it's kind of like you're out at the launch site and you're getting ready to launch your rocket. So imagine that's your situation. You're at the launch site, you have your rocket, and you're ready to launch. But to prepare that rocket for launch, we have to start putting in things like the rocket motor. And that's the first thing, and that's the first screen that comes up, is engine selection. So what engine do you want to put in here? So if I go down here to the body tube and I double click on it, I can open up the motors, or I could just highlight it and choose the Choose Engine button. So I'm going to double click on this, and that will bring up my engine selection screen here. So now this is showing all the rocket engines that will physically fit inside this rocket design. This design, it's not the one that I'm holding, but it's the one on the screen. The Aspire rocket is in a 29 millimeter diameter rocket. So it can take 29 millimeter diameter motors. So it's showing only those engines that can match the motor mount diameter. And there's probably over 100 different rocket motors right here. So that's why you're seeing so many. So now which one should you pick? The answer is, it doesn't matter. You can pick any motor and run a simulation. And that's the beauty of this is, and what I want to train people is, don't be afraid to pick a motor and just to see how it works. So I'm going to pick an Aerotech E16W. Now I also need to pick a delay, because when you pick a motor, you have to pick the delay with it. Right now it's showing the delay is plugged. And I'm going to go down here, just click on that drop-down menu, and I can see on this particular motor, there's actually 2 standard delays, and there's also plugged and custom. And we can get into that a little bit later. But usually what I do is I always pick the longest delay from the list when I'm first starting out. So I'm going to pick the 7, and then I'm going to pick OK. So now when I do that, it comes back to this screen, and you can see that now the back of the rocket, the engine is shaded in. And if I come over here and I look at this screen, if you look closely, you can see that the rocket has an engine inside of it now. Okay. I was just checking for questions there. So now the engine is loaded, and I want to go across these tabs along the top. So flight events control when things happen during the flight. Now there's usually 2 events. One is staging, and the other is parachutes and streamers being ejected. And this particular rocket has both a streamer and a parachute in it. Normally it would just have a streamer, but since this is one of my personal designs, I've been playing around with dual deployment. So I put in a streamer and a parachute so that I could run dual deployment. But I'm going to just say, let's just use the streamer for right now. So on the parachute, I'm going to say no event. So that means ignore the parachute for right now. And for the streamer, just let's deploy this at maximum engine ejection. And we already chose the engine ejection at 7 seconds. So at 7 seconds after the motor burns out, and this is measured from when the motor burns out, not from when you hit the launch button. So when the motor burns out, start counting 7 seconds after, eject the streamer from the rocket. So now we have our flight events set up. This is a single stage rocket, so I don't have to worry about when staging is going to occur. Simulation controls, just ignore this for right now. Starting state, you can kind of ignore this. I want you to get to launch a rocket as quickly as possible just to figure out what's going on. And at this point, I can launch the rocket, or I could go through, more setup, like what is the launch angle of this rocket? I'm just going to, right now it's set at 0 degrees, so it's launching straight up, and it has a 36-inch launch rod. Is this long enough? I don't know. At this point, it's all in the computer, so it doesn't matter. You're not going to hurt anything. Just launch it. So now I'm going to go to the launch condition tabs, and this is, where are you launching? Because this affects the flight of the rocket. For right now, I'm going to ignore whatever the settings are on the screen. I'm just going to launch it. So now when you launch it, you have two things that you could look at. You could just run a simple launch and get simple results back, or you could run a flight profile. A flight profile is run a simple launch, but also show me what the rocket trajectory looks like. And I always recommend that people look at that trajectory, because this is more important than just how high it flies or how fast it flies. I want to know where it's going. That is more important than how high it goes. So that's the first thing that you always want to look at when you run a simulation. So I always run the flight profile. So I'll run the simulation. So Rocksim right now is it's running the simulation, figuring out how the rocket is flying, and then it's going to bring up the 2D flight profile screen. So that's what you're seeing here right now. Down here on the bottom corner of the screen, we see a little tiny rocket, and we see some range distances from the rocket with little tick marks. So the first one is 100 feet away, and then 400 feet away. Down here, it's really hard to see. By default is the little rocket, but you can see that. And then you have these black vertical lines going off to the side right here. It is something that we introduced in Rocksim version 10. We call this the weathercocking cone, because people always ask to me, if you're looking at the simulation, is it good? Is the rocket performing okay? For most people, they don't know. For somebody that's brand new, they don't know. So what we did is we instituted this weathercocking cone as a little bit of a guide to discern whether or not the rocket is actually flying properly. So if the rocket flies in this cone and the apogee point, and the apogee is the highest point in the flight, if the apogee point is within that cone, we're going to call it a good flight. So here on this screen, there's like a little launch button over here. It's kind of like an animation. So I'm going to go ahead and just start the animation playback. And you'll see the rocket take off and start moving. And it's going mostly straight. Good, I like to see that. And it's going up to its highest apogee point. And apogee point, now it's starting to descend. So now I know it's gone beyond apogee point and it's starting to coming down. So that highest point is within the cone. So this is a good flight. So if I wanted to fly this rocket with this particular motor, I know it's okay. So that's your criteria of knowing whether or not the motor that you've picked will work okay with this rocket. If that apogee point is outside of that cone or the trajectory loops, that might be something you might not want to use that particular motor, or your launch conditions are not correct. And this is in real time, so right now we're about 1 minute into this flight and the rocket is descending back down. But you'll notice right here we also have a scroll wheel. It's not really a wheel, it's a scroll bar where you can drag and go back into time and see what's happening at different points. So now you see this stuff down here. This is smoke, because your rocket's going to crease off, and we put that smoke in the simulation for a specific reason. It's not there just for looks. It provides information, and the information it tells me is smoke drifts with the wind. And right now this smoke is drifting off to the right, so I know I have wind coming from the left of the screen moving to the right. So this is the visual indication of the wind direction, because when you go out to the launch, when you're launching a real rocket, you're going to see wind, and you're going to want to know what those conditions are. And also down here on the bottom right side of the screen, we have altitude of the rocket at any given instant in the flight, and also the range. The range is how far away from the launch pad is the rocket at this particular point. So this rocket with the E16 motor is going to go about 2,400 feet approximately. I don't know what the exact altitude here is. 2,500 feet altitude, and it's going to drift when it comes back down approximately 423 feet from the launch pad. So we've run the first simulation, and look how much information that we've already got just by looking at this one screen. We know the trajectory of the rocket, which you don't get by just looking at a simulation summary screen. And this is what makes Rocksim so powerful, because we were the software to do this. It's more important to look at that trajectory than just the summary of the rocket. And this is why we put it in there, and why I always recommend that you look at the flight profile. You can learn a lot, because people will send me designs all the time and they'll say, why didn't the rocket go as high as I thought it was going to go? And they're just looking at a summary screen, where I'm looking at the flight profile. And what I might see is the rocket, doing loops. That's why your rocket didn't get as high as you thought. Or maybe the rocket, instead of going vertical, went horizontal. Again, that's going to tell me why your rocket didn't go as high as possible. So I want you to use the most important tool that you have, and that's your brain. The human brain is remarkable in being able to predict the future and to do compare and contrast. So now we're doing that thing that brains are really good for, comparing and contrasting, what you expected to occur and what actually is going to occur. And then when you go out to the launch site and it doesn't match this, now we can do that again. This is the fun of Rocksim. So now I'm going to close this window out, and it's going to take me back to the main view of Rocksim. And you can see now the main screen has changed. Before we were on the Rocket Design Components tab, now we're on the Flight Simulations tab. And this is by default because we've just run a simulation. And so now it's throwing up a summary of that particular flight. So now we get the maximum altitude. But that maximum altitude depends on the launches and our launch angle. So do you remember what we did when we first started? We launched straight up. So what would happen if we launched at an angle? So that's what I want to do next. So I'm going to go back to the flight preparation screen, and I'm going to go to the starting state. Remember, the starting state, originally we had a launch angle of a launch rod of 36, and the launch angle of 0. So now we know what our launch angle is. It's 0, and now we're going to adjust it. But we can adjust it either way. We can go this way or that way. But remember, we had wind coming from the left side of the screen pushing to the right. So if I angle to the left, I'm going to be arcing into the wind. And if I angle to the right, I'm going to be going with the wind. So which way should we go? Well, this is the cool thing. It doesn't matter. We can run the simulation and find out how it affects the flight. So the first time, I'm going to launch into the wind, and I'm going to say 15 degrees, and you can use this slider wheel right here to make that quick change. But if you want an exact measurement, go down here and just type in a value. So I'm going to highlight and erase the 0.999 from the screen, and then I'm going to hit tab, and this forces Rocksim to accept the value. So now I'm going to launch at 15 degrees. So I'm not going to change anything in the flight. I'm just going to hit the flight profile one more time, and the Rocksim is going to rerun the simulation, but this time we got the launch going into the wind. Okay, so you can see the screen is pretty much the same, although now it's shifted the rocket's position from the left corner of the screen, and it's moved it more towards the center. Because what Rocksim figured out, it needs more room to display the trajectory, so it shifted it for us. So now down here is our rocket, and if I click the launch button again, we're going to see that trajectory. The rocket's taking off, and it's out of the cone. This is one of the criteria we had for a good flight, is that apogee point has to be within that vertical cone. So now I know that this particular condition is not desirable. So the rocket is going more sideways than it is straight up. And straight up is always the safest direction you can launch a rocket in. When I say straight up, I mean mostly straight up. Now the NAR has done something brilliant. They say when you launch a rocket, never launch it straight up, at least 5 degrees away from spectators. So if I got spectators behind me, I want to launch at least 5 degrees away from spectators. Never over spectators, but at least away from spectators, so that when the rocket goes out, it's going to be away from the spectators. And this is for safety. It's, you're not going to get as great of an altitude because you're angling the rocket, but for safety, definitely do. In Rocksim, you can go straight up, but in real life, angle away from spectators. We have a question from I am Dignant from India. My question regarding stability of a model rocket. Generally, I love to show actual stability, that is CGCP, with the help of string test. But if I use Rocksim, I can able to do stability on Rocksim and launch. Let me go over here, see more. On Rocksim and launch as per Rocksim, it works fine, but how can I show the stability of a rocket to the students on Rocksim like a string test? Okay, so let me go back here. So we've run the simulation. I'm going to go back and answer the question from Dignant. So again, it always comes back to the flight simulation screen, and it's going to show the results of our. And this is just a quick summary. So here it showed that our rocket went 2,100 feet, almost 2,200 feet on this particular flight. So now I want to go back to Dignant's question. You want to show where that center of pressure is. In Rocksim, in one of the side views of the rocket. In Rocksim, we have 2 side views. It's actually a side view and a top view. So a side view is looking at the rocket. Let's see if you can see my picture here. You're looking at the rocket from the side, and in this particular case, I got part of the top fin and part of the bottom fin. You're seeing that. But if I change it to a top view, you can see, oh, this particular rocket's a 4-fin rocket. Why didn't it change? Because on 4 fins, no matter the top view and the side view are going to be the same. But if it's a 3-fin rocket, the fin orientation changes. This becomes important if you have a rocket that has fins or wings like an airplane. The top view is going to look different from the side view. But where is the center of pressure? We kind of covered this at the very, very beginning. The center of pressure is this symbol back here on the rocket. It's a circle within the circle, and the inside circle has been shaded in. The color may change. Don't worry about the color. It's the icon itself, a circle within a circle, and the inside circle, it's shaded in. That is our center of pressure location. If you're showing this to students, that is what Rocksim is calculating it. Remember, the center of pressure is where all the aerodynamic forces on the rocket are said to balance. So when the rocket takes off, we have lift and drag. Those are the two aerodynamic forces. Drag is trying to hold the rocket back, and lift is trying to, it depends on the orientation of the rocket. Lift is always perpendicular to the direction of the rocket is going. So if the rocket is going upwards, lift will be off to the side. And what creates the greatest lift is the fins. And this is why we put them on the back. And this is to create stability for the rocket. We don't put them on the front because that will make the rocket unstable. Can you show stability in a live demonstration like a string test? And the answer is maybe, but you're going to need some other equipment. And the equipment you're going to need is a wind tunnel. And on our website, I have plans for a rudimentary wind tunnel that you can build with an electric fan, like a box fan that you might stick in the corner of a room. So we're going to build, using cardboard, just build a little funnel that's going to come down and funnel all the air, so all the air from the fan comes out nice and straight. And if you put the rocket in front of that fan and you grab it with a caliper, and if you have the caliper right at the center of pressure location, the rocket shouldn't spin, because that is the definition of the center of pressure, is where all the aerodynamic forces balance. So here's the center of gravity. So if I get it balanced just right, it shouldn't move at all. And on the center of pressure, if you get the center of pressure located just right with the caliper and you have air flowing over it, the rocket won't move. And usually what you do is you don't have the air coming in hitting the nose cone. You have it coming in hitting the side, because that means we know we've got just as much air pushing on the front as on the back. And that's going to be our center of pressure location. But know this, that the center of pressure location is not a static location. So this is why it's kind of fuzzy. Center of pressure depends on the orientation of the rocket. So our center of pressure with the air, if the air was coming this way straight, hitting the rocket so that you can see it, is going to be different than if it came from this orientation. The worst case orientation is when the center of pressure is at its furthest forward, and that's if the rocket is flying sideways. So if the rocket was going up like this and it was going sideways, that's the worst location, or the furthest forward that the center of pressure will shift during the flight. So it will go no further forward than that location. Normally it will be behind there. So this is getting in to center of pressure location, and why it's very tricky to figure out. Rocksim uses what's called the Barrowman static center of pressure location. So in static center of pressure, we're assuming a specific condition. That means the air is coming, hitting the nose first, and the rocket is going straight into the path. If the rocket is at an angle, Now our center of pressure moved. The Rocksim tries to estimate the new center of pressure location, but will it be exact? No. The best situation is when the rocket is going straight up into the air. That's going to give you the most accurate simulations. So hopefully that answered your question, Dignit. Okay, so we've got just a few minutes left in this video. I said I only wanted to go an hour, so there's only a couple minutes left. So I want to just say thank you for participating. Right now, we've got 18 people, 21 people that are viewing live, and I really appreciate you coming. I didn't expect 21 people, like I said at the very beginning. I expected only maybe like 1 or 2, and those people being inside the office. This is our very, very first Facebook Live video, and we're just testing the technology, making sure it works. As you can tell, I've got multiple things going on here. I've got a camera directly in front of me. I'm not using it on my laptop because otherwise you'd see the ceiling, because I have to tilt my laptop and see it better. I have another monitor off to the side here that you can't see, and this is where I'm monitoring the questions that you have asked. And I see something else came in from Tom. Tom says, I appreciate you doing this. Thank you, Tom. I appreciate you coming. This is a two-way interaction, and I appreciate the comments as well. So anyway, I got distracted. So we're testing our technology right now. I'm also using a lapel microphone. I'm not using the microphone on my computer. So there's a lot of different things going on here. This is our first time. I want to do a big shout out to Bobby Potter. Bobby Potter is our marketing guy here at Apogee. Set this all up for me. I'm not smart enough to do this myself. Thank you, Bobby. I really appreciate it. Again, I appreciate you so much. They're on this long. If you are new to Apogee, come to our website. Our website is www.apogeerockets.com. Let me bring that up here on the screen for you. On our website, let me move this screen off here, or you can see. I was looking for, on our screen, we have a newsletter sign up, and that's this big banner. If you're new to Apogee and you want to learn more about this, the best way for us to communicate to you is through our newsletter, because we do this once a week. We send an email to you announcing our newsletter or our newest video. And the newsletter contains how-to information. Now, it's going to make you a better rocketeer. We also do videos, which I'm sure you're familiar with. A lot of people come to our website through our videos. So we send out notifications when there's new videos available. But when you sign up, you get a book. We have a free gift, and that book is a book of plans, 25 rocket plans. They're all fairly small, simple to build rockets. You get the designs, you get the Rocksim file, so you can open those up and experiment with different rocket motors. And you get a 2D drawing of it, all the dimensions drawing, plus you get the decals as well, so you get a nice looking rocket. And the decals you have to print out yourself, obviously, because we can't give you the decals, but you can buy the decals separately. We have them in vinyl, like these are vinyl decals right here, where we make them in-house. We sell those separately, but you don't have to buy them from us. You can print them out yourself on your own printer. So anyway, there's that. So that is our very, very first Facebook Live. Next time, what I think I'll do is I'll if there's no questions, maybe we'll start with running recommended motors. So I've shown you just running a simple rocket motor. Now let's try to do recommended motors. And so anyway, there's that. So But if you have a question, we're going to try to answer those first. Those are the highest priority because what you want to know is what matters to me. So my name is Tim Van Milligan. This is the Apogee Facebook Live. We'll probably put this on YouTube as well so that people can look at it at multiple locations. So this is where I end the video. So thank you for coming. Bye.